12.2 The applications of capacitors. So here this circuit is called rectifier circuit. It shows one application of using capacitor. This circuit itself is called a rectifier circuit, or simply rectifier. It is used to convert AC to DC, where AC means alternating current and the DC means direct current. This circuit does the job. And if you look at the input, the signal on the left-hand side, that sinusoidal waveform is the input, is the AC signal. That applies to AC voltage or AC current. And then the signal on the right-hand side, labeled as Vout, which means output voltage. That dark blue signal is the output waveform. As you can see, the output waveform looks like small hills or small bumpers adjacent to each other. It doesn't look like a real DC signal, which should be a straight horizontal line, as shown here. One way we can make it look similar to a straight line is to connect a capacitor. We put a capacitor in parallel to the load resistor RL. At the end, the output waveform looks like this. It smooths out those bumpers. This is how it works, because capacitors can store charges. When we implement it here, when the voltage reaches to the peak, and then it starts to discharge, it only discharges a little bit and then the signal goes up. It starts to charge, but it only can charge to a certain limit, which is the second peak, and discharge again, charge, discharge. So as you can see, the output waveform is a smooth out signal. It looks kind of flat now. At least it's flatter than before, than without using this capacitor. Of course, we need to implement different technique later to make it like a straight line. The following slides shows different applications of using capacitor. These applications or the designs are called filters. There are a few different kinds of filters. The first one is the low-pass filter. As you can see, we connect a resistor R in series to a capacitor C. The voltage across the capacitor is the output voltage. If you build a circuit like this is called the low-pass filter. And this is how it works. The F sub L means the lower frequency. This frequency depends on the value of resistor and the capacitors. If the signal entering to this circuit has frequency higher than that FL, this circuit will remove that signal. If the signal has frequency less than the FL, it will come out from that circuit. So low-pass filter is a kind of filter only lets signal with lower frequency go through, and it removes any signal higher than that frequency FL. If we rearrange this circuit, or using the same circuit but take the output from the resistor, this is a high-pass filter. For this kind of filter, it lets signal with high frequency go through. If the signal has frequency lower than the set frequency, FH, it will be removed. Again, that frequency FH determined by the value of resistor and the capacitor. Here is another type of filter called a bandpass filter. It's just a low-pass filter and high-pass filter combined. In this case, we can let signal between certain frequency ranges to go through. Remove the signal outside this range. This is called a band stop filter, which is the opposite of bandpass filter. For an input signal, its lower frequency region and the higher frequency regions can go through, but not in between. This is another application of using capacitor. It's an audio amplifier. As you can see, this is a pretty complicated circuit. it has different kind of devices such as those L, the inductors, capacitors, resistors. There is a semiconductor device called transistor, and the output connects to a speaker. As you can see, there are lots of capacitors in this circuit. This is another application of using capacitor. The device in the center with 4 legs on each side, together 8 legs, that device is called a timer, such as the popular 555 timer. We use the capacitor with this timer to generate a clock signal, where the clock signal is just the heartbeat of the digital device. For example, these devices can be the logic gates, digital flip-flops, the counters, registers, or CPUs, central processing unit. By choosing the correct resistor and capacitor values, this timer can generate 1-second clock waveform. If you connect this timer to a counter, such as an up counter, the counter counts up at 1 second rate.